we are told that human civilization progressed in a relatively linear fashion. Small settlements gave way to villages. Villages gave way to towns. Towns accumulated resources, developed tools, organized labor, and eventually produced the architecture we associate with advanced societies. The timeline is presented as coherent. The progression is presented as logical. And for the most part, when historians describe the great building projects of previous centuries, they describe them as achievements that took time, sometimes decades, sometimes generations, to complete. That is the framework. Now consider a specific problem within it. When European colonial administrators, military surveyors, and early cartographers arrived in various parts of the world during the early 1800s, they documented in their own records structures that the local populations could not explain. Not structures that were old in a vague cultural sense. Structures that were already functioning, already intact, already in use, or already abandoned, with no surviving account of how they had been built or by whom. The administrators wrote this down. The surveyors measured it. The cartographers drew it, and those records still exist. The question isn't whether the buildings were there. They were. The question is what was already standing before the century that supposedly built them had even begun. There is a class of pre-19th century architecture that presents a consistent technical problem. The problem is not aesthetic. It is not a matter of interpretation. It is a matter of material physics. In dozens of documented locations across South Asia, Central Asia, parts of South America, and sections of Europe and North Africa, there exist stone and masonry structures whose internal geometry, the precision of their vaulted ceilings, the tolerances of their fitted joints, the load distribution of their arched corridors, require a level of structural calculation that the official historical record does not assign to the periods in which they are placed. Take one specific case. The network of structures across the Indian subcontinent that were documented by British colonial engineers in the early 1800s, when those engineers, men trained in the technical standards of Napoleonic-era Europe, which were themselves considered advanced, wrote their assessments. Several of them noted that specific buildings they were cataloging showed construction techniques they could not immediately identify. Not ancient ruins, not crumbling remnants, functional, standing, geometrically sound buildings. Some were being used as administrative centers, some as residences, some had been converted, repurposed, built around, or built upon. But the original core structures showed characteristics that prompted technical questions the engineers recorded but did not resolve. One recurring observation: mortar joints so thin they required magnification to measure reliably, in stonework so level that modern laser instruments, when applied centuries later, have confirmed deviations of less than 2 millimeters across spans of several meters. This isn't a matter of interpretation. It's a measurement. The official explanation for how that precision was achieved, hand tools, empirical estimation, skilled craftsmen, doesn't account for the repeatability of the result. Skilled hands can achieve precision. They achieve it inconsistently. What appears in these structures is systematic precision. Those are not the same thing. The mortar question deserves more attention than it typically receives. Across multiple continents, in structures dated to periods ranging from several hundred to over 1,000 years ago, the binding compounds used between stone elements have been analyzed with modern spectrographic equipment. The analyses have been published. The results are not contested. What is contested, or more precisely, what is quietly avoided, is what those results imply. In multiple cases, the chemical composition of ancient mortars shows the presence of compounds that require sustained high-temperature processing, above 900 degrees Celsius in some analyses, combined with specific mineral combinations that would require either prior knowledge of those minerals' properties or a degree of experimental refinement that itself implies a history of development. That history is not in the record. Roman concrete is the most cited example, and it receives a relatively generous amount of academic attention. The volcanic ash component, the seawater curing, the self-healing crystalline structure, these are documented. But the documentation of how Roman engineers came to understand these properties is almost entirely absent. We have the formula. We do not have the development of the formula. We have the product. We do not have the accumulated trial and error record that should precede it. This is not unique to Rome. In pre-Columbian Mesoamerica, binding compounds with comparable chemical sophistication appear in structures dated centuries before contact with Old World traditions. In parts of Southeast Asia, temple complexes show mortar chemistries that have not been fully replicated by modern conservation teams attempting to restore the original material. The teams can approximate it. They cannot match it. The structures they are attempting to repair are, by the official timeline, less technologically sophisticated than the institutions doing the repair work. That is a specific kind of anomaly. It is not dramatic, it is technical, and it does not resolve neatly. There is a pattern that appears consistently when pre-19th century structures are examined across geographic regions without the assumption of cultural isolation. The pattern is this: certain techniques appear at full sophistication, function at high performance levels for a period, and then cease, not gradually. Not in the way that technologies typically decline through reduced funding or shifting priorities. They cease in a way that leaves no intermediate record, no simplification phase, no degraded version, no period of lesser competence. Hydraulic systems are one example. Across the Roman world, across the Indus Valley, across pre-Columbian Peru, and across sections of ancient Sri Lanka, water management infrastructure exists that required precise gradient calculations, underground channel construction, and pressurized distribution systems. These systems worked. Some still work. And in each case, after the civilization associated with them declines, the knowledge of how to build them disappears from the regional record. Not the knowledge of that water comes from elevation. The knowledge of how to calculate the tolerances, seal the joints, and maintain the pressure differentials. That specific knowledge vanishes. What comes after, in some cases centuries after, is not a continuation. It is a restart. Medieval Europe's relationship to Roman hydraulic engineering is an example. Medieval engineers did not build on Roman hydraulic knowledge. They rediscovered it, slowly, imperfectly, from physical examination of surviving Roman structures. They were learning from ruins. The ruins were teaching them things their own civilization did not know how to do. This raises a question about the nature of technological inheritance. If knowledge is truly cumulative, if civilizations build on what came before, then the gaps should be small. Techniques should degrade slowly, be partially retained, be modified rather than abandoned wholesale. What the physical record shows, in multiple independent cases, is not degradation, it is discontinuity. Something was known. Then it was not known. Then, much later, something like it was rediscovered by working backwards from the surviving objects. The survival of those objects is itself worth examining. When a technology is lost, the objects it produced typically follow one of two trajectories. They are destroyed through conflict, neglect, or deliberate removal. Or they are preserved, but preserved in a way that separates them from any functional understanding of their origin. They become artifacts. They are placed in museums, incorporated into later buildings, protected behind glass, labeled with approximate dates, and described in terms of what they are, rather than how they came to be. This is not necessarily deliberate. Institutions preserve what survives. They describe what they can measure. The absence of explanation is not always concealment. It is sometimes simply the limit of available evidence. But that limit deserves acknowledgement, and it does not always receive it. In numerous cases across the academic literature on ancient construction, the methodology section of a given analysis will note in careful language that the specific technique used to achieve a particular result remains unclear or has not been fully determined. These phrases appear in peer-reviewed publications. They appear in the supplementary materials of major conservation projects. They appear in the internal reports of UNESCO heritage site assessments. They are accurate. They are also in the context of the broader public presentation of those sites, rarely foregrounded. What the visitor to a heritage site typically receives is a confident narrative, a date, a civilization, a method described in general terms, chisels, ramps, organized labor, that creates the impression of a complete explanation without providing one. The official explanation accounts for that of these structures, but not consistently for the how. The labor question is one that receives more public attention than most, and so it is worth examining carefully rather than dismissively. The standard model for large pre-modern construction projects relies on organized mass labor, sometimes slave labor, sometimes conscripted labor, sometimes voluntary labor organized around religious or civic identity. This model is supported by textual evidence in some cases. Egyptian administrative papyri document worker rosters and supply chains for certain construction projects. Roman military records document engineering corps. Inca Mita labor obligations are documented in Spanish colonial records. But the documentation is not uniform, and the documentation that exists does not always connect cleanly to the physical evidence. The Great Pyramid at Giza is perhaps the most analyzed construction project in human history. The labor model, tens of thousands of workers, organized in rotating teams, supplied by a sophisticated logistical infrastructure, is supported by the discovery of worker villages and administrative records. That part of the explanation is on reasonably solid ground. What is on less solid ground is the precision component. The worker villages explain the labor capacity. They do not explain the angular tolerances. The logistics explain how stone was moved in large quantities. They do not explain how the casing stones, now mostly removed, but documented by early Arab historians and measured where they remain, were fitted with tolerances of less than half a millimeter across faces several meters wide. Those are two separate technical problems. One of them has a plausible answer. The other does not. The official explanation tends to present both as resolved, when only one is. There is a geographic dimension to this problem that is difficult to account for under the standard models of ancient contact and cultural exchange. When you map the locations of structures exhibiting certain specific technical characteristics, particular types of polygonal masonry where irregular stones are fitted without mortar to extreme tolerances, specific styles of corbelled vaulting, certain approaches to underground acoustic design, the distribution does not follow the known paths of ancient trade and cultural transmission. Polygonal masonry of the type found at Sacsayhuaman in Peru. Large, irregular, multi-angled stones, fitted with no binding compound to tolerances that have been verified by modern measurement, appears in a functionally identical form in structures in parts of Greece, Turkey, and the Italian peninsula, dated to comparable pre-classical periods. The standard explanation is independent development, that similar problems produce similar solutions. This explanation is applied across many fields and is sometimes correct, but the degree of similarity here goes beyond problem-solving convergence. The specific aesthetic of the technique, the specific scale of the stones, the specific approach to the fitting geometry, these are not just similar solutions to a shared problem. They are, in many cases, nearly indistinguishable. Independent development can explain why two cultures build walls. It does not straightforwardly explain why two cultures separated by an ocean build walls using the same irregular polygonal fitting approach at the same scale without mortar to the same tolerances. One can argue for coincidence, but the argument requires increasingly specific coincidences across increasingly specific technical decisions, and at some point, the coincidence explanation becomes more difficult to maintain than the alternative it is intended to avoid. The alternative, that these techniques reflect a shared origin or a shared transmission that the current historical record does not document, is not stated here as a conclusion. It is stated as a question that the coincidence explanation does not fully answer. The early 19th century is a useful analytical window for a specific reason. It sits at the intersection of two things: the beginning of systematic, written, technical documentation of existing structures by trained observers, and the period just before industrial construction techniques began to alter the built landscape at scale. What survives from the written record of that period? The survey reports, the administrative assessments, the engineering observations of colonial officials, the notes of early archaeologists, contains a consistent thread that is rarely highlighted in secondary literature. That thread is uncertainty. Trained observers, encountering structures that the official historical narrative placed within known civilizational contexts, repeatedly noted that those structures did not fully match what they would have expected given the assigned context. A British survey of temple complexes in South India in the early 1800s contains passages that describe the precision of stone joinery as exceeding what the surveyors could explain by reference to known Indian historical construction methods. An early French archaeological report on structures in North Africa notes the presence of internal chambers whose acoustic properties appeared to be intentionally designed, a degree of architectural intentionality that the report's author considered inconsistent with the assumed technological level of the builders. A Spanish colonial inventory of structures in the Andean highlands describes buildings whose foundations showed no signs of the construction methodology that had been assumed, no tool marks consistent with the available stoneworking technology of the period, no evidence of the fill material that would have been expected given standard Andean building practices. These observations were not published as anomalies. They were filed as administrative records. Some are available in national archives. Some have been partially reproduced in specialized academic literature. None of them are part of the standard public narrative about the buildings they describe. The evidence doesn't disappear. The explanation does. the question of what was standing before the 1800s began, has a specific dimension that is under-examined, the matter of existing infrastructure in cities that were supposedly being developed during the 19th century. When Western colonial administrations established or expanded urban centers across Asia, Africa, and the Americas during the 1800s, they frequently did so by building within or around existing urban infrastructure. Roads were extended from existing roads. Administrative buildings were constructed on existing foundations. Water systems were connected to existing channels. The colonial record documents this. It is not a matter of interpretation. The surveys note pre-existing streets, pre-existing drainage, pre-existing structural foundations that the new construction incorporated. What is less documented is where that pre-existing infrastructure came from, who built it, and when. In numerous cases, the structures that colonial administrations incorporated into their urban projects were attributed to the most recent identifiable pre-colonial civilization in the region, but the attribution was often made by inference, by the absence of an earlier candidate, rather than by documentary or material evidence. The structure was there, someone must have built it. The most recent known civilization was assigned responsibility. This is not fabrication. It is how historical attribution often works under conditions of incomplete evidence. But it means that a significant portion of what we designate as, say, Mughal infrastructure, or Ming period infrastructure, or Aztec infrastructure, may in fact be infrastructure that those civilizations themselves inherited, modified, and maintained, rather than built from the foundation up. The distinction matters because it affects the question of what technical capability those civilizations actually possessed versus what technical capability they were the custodians of. The buildings were there. The question of who built them in the first instance remains, in a number of cases, genuinely open, though it is not always presented that way. Modern replication attempts provide a specific kind of evidence that is sometimes cited in popular discussions but rarely examined in detail. Over the past several decades, a number of engineering teams, academic institutions, and independent researchers have attempted to replicate specific construction achievements of ancient civilizations using only the tools and methods the official historical record assigns to those civilizations. The results of these attempts are instructive. Some elements replicate reasonably well. Moving large stones using sledges, levers, and organized human labor, feasible, demonstrated, plausible. Cutting stone with copper or bronze tools, possible, demonstrated, though slower than the timelines often assigned to large projects would comfortably accommodate. What does not replicate well is precision. The cutting of faces to tolerances under a millimeter using hand tools has not been demonstrated at scale under controlled conditions. The fitting of irregular polygonal stones without mortar, each face of each stone contacting each adjacent stone across its full surface, has not been replicated for large stones using only the tools assigned to the relevant historical periods. Conservation teams working on sites like Sakyamun, attempting to reposition stones that have shifted, have used modern equipment and still struggled to re-achieve the original fitting tolerances. This is not a fringe observation. It is documented in conservation literature. The teams doing the work are not making an argument about ancient mysteries. They are reporting a practical engineering difficulty. The fact that they find it difficult is itself a data point. These are professionals with modern tools, attempting to match the work of people who, according to the official record, had far less. The question isn't whether ancient people were capable of extraordinary things. They demonstrably were. The question is whether the explanation we have for how they did specific things is complete. The conservation reports suggest it is not. There is a category of absence in the historical record that is worth isolating, because it is specific and consistent. For many of the techniques discussed here, extreme precision fitting, advanced mortar chemistry, hydraulic gradient calculation, acoustic chamber design, there should exist, if those techniques were developed within the historical periods assigned to them, an archaeological record of that development. Failed experiments, transitional structures showing lesser versions of the technique, waste material from the refining process. Records of instruction, whether textual or pictographic, for some techniques, portions of this developmental record exist. Egyptian papyri include engineering diagrams. Roman texts include discussions of concrete mixing. Chinese historical records include descriptions of construction methods. The developmental record, while incomplete, is at least partially present. For other techniques, specifically the ones that present the greatest technical difficulty, the developmental record is largely or entirely absent. The technique appears, It is applied at high sophistication. It continues for a period. Then it stops. There is no record of the learning curve that produced it, and there is no record of the degradation process that ended it. This pattern, full capability then absence, with no documented development in either direction, repeats across enough independent cases that it constitutes a pattern worth examining rather than explaining away. Each individual instance might have an individual explanation. The consistency of the pattern across cultures, across continents, and across different technical domains is harder to attribute to individual circumstances. What this investigation has examined is not a single anomaly in a single place. It is a category of anomaly that appears with enough regularity across enough independent contexts to constitute something systematic. The technical precision exists. It is measurable. The official timelines exist. They are documented. The tools and methods assigned to those timelines exist. They are analyzed. When these three things are placed next to each other, in specific cases and with specific measurements, they do not consistently align. The early 1800s records of pre-existing infrastructure exist. They are in archives. The attribution of that infrastructure to the most recent known builders exists. It is in the historical literature. The evidence that the attribution is in some cases inferential rather than demonstrated exists. It is in the fine print of the same literature. The replication failures exist. They are in conservation reports. The missing developmental record exists, or rather its absence exists, and that absence is noted, briefly, in the same academic papers that otherwise present confident accounts of ancient construction. None of this proves a specific alternative. The evidence here does not support a single clean counter-narrative. What it supports is a more limited and more precise conclusion that the standard account of what was built, when, and how contains gaps that are not consistently acknowledged in the public presentation of that account. That some structures we assign to specific periods and specific builders may have a more complicated origin than the assignment implies. That techniques we describe as developed within known historical frameworks may have been inherited from a framework we have not yet identified. The buildings are still standing. Several of them have stood through multiple civilizations, multiple conquests, multiple administrative regimes, each of which incorporated them, built around them, labeled them, and moved on without fully accounting for them. What the early surveyors found, when they began systematically documenting what was already there, was a built world that exceeded the explanation available for it. That gap between what was built and what we can account for has not closed. The structures remain. The method, in a significant number of cases, does not.